Okay, Timmy, here's your video as promised. This R107 on this schematic is 100K. Notice it comes off the plate of the vertical out where it connects up to the blue lead of the vertical out transformer. And we'll have to go to the next page. Let's see if we can follow this along. It's that fourth one in. Well, maybe I can see a little bit more of it here. Alright. I believe it's going to be this lead right here. So let's go to the next page. I don't think I can see it all. Nope. So now we have to go over here. Alright. It's this line right here. So I think that's R107, cap C41, and R67 goes to this video out, and that's where it injects an additional blanking pulse at the vertical rate. Now where is that on the PC board? Might be a little bit harder to find. Let's see here, R107, is it on the bottom of this? You have to bear with me for a minute here, folks. I'm going to try to find this for Timmy. I think it might be in here somewhere. Okay, here we go. Zoom in on this. Here's R107, Timmy, right here. Assuming this is a CTC 12 clone. There's a little resistor right there. I believe that's 100K. So you want to check that. And this is isolated from the circuit, so you should be able to just get a meter reading right across that. And then we want to go to the chroma board, and I zoom in a little bit more. R107 right there. And now we got to go find the chroma board. Find the chroma board. Alright, it's going to be right down in this area over here. Okay, I believe it's, I think I said it was R67, was that correct? I think it's this one right here. Okay. And this is that disc cap right here. Should be the cap we're looking at. Let's see what's over on this side. Let me back up. Shoot, it doesn't have the caps on the same thing. Probably the next page down. Oh, here you go. Here's your C41 right here. Okay. And I think if you look at this, when you look at the chassis, you'll see there's a wire that literally comes from here and loops back over to that other board to make that connection. But these two guys here are the ones that I would suspect as being the two that could be a problem. I think that's a 68K, and that's the 0.01, and then that other one on the deflection board. Those are the ones that I'd be looking at if I had a blanking issue. That's assuming the setup is done correctly of the CRT. You know, you have to make sure you have the let's see if it has it over here. Assuming you've done this. Let me go over here. Tune in a black and white picture. Color, see, color set to minimum. Turn the kin bias fully counterclockwise, or if you have the switch type that's all the way up on the 3-position switch. Red, blue, green screens are fully counterclockwise. Move the service switch to the service position. Advance the controls one at a time until it just barely produces a visible line. If any controls fail to produce a visible line, then you have to advance the kin bias, either the pot or the switch, move it down to the middle position, and then redo that. Keep doing that until you can just get a barely visible line, and then adjust the other G2 controls. That's the red, green, blue, not the little, not the drive. That there's a, let's see, there's 3 controls that are on the far right hand side looking at the back of the CRT. Those are the G2 drives. The G1 drives, actually I think it's the cathode drives, are the ones that are just the red, just the green and just the blue. Those are for adjusting the white areas. The red, the drive ones, the 3, are really, you're trying to get a uniform gray on a dark area, and the other drives are the blue and the green are for the highlights. If you're not doing this minimum, set the minimum, you're not doing this kin bias part right, then you're kind of like you're not even starting properly. So you need to get this working. And if you have a strong CRT or a good CRT with good cutoff, and you've set this up properly, and your AGC is set right, and you're getting a normal picture, and your contrast is correct, you should be able to advance the contrast to the correct contrast. If all that's working right, and you still have noticeable vertical retrace lines as defined by my earlier video, then those 2 resistors in that cap could be a problem. You go ahead and check it. Now you're going to want to check that those resistors, they could be off a little bit. Don't expect them to be exactly 100K. It might be 110, 150, 120. The 68K might be 75, 80K. That's not going to make that much of a difference. At the 0.01, I don't think you can check that. No, I'm pretty sure you won't be able to check that in the circuit. I'm not even sure if you can check those other 2 in the circuit. 100% sure about that. You have to look at that schematic again and see. But if they're like a mega ohm, you have a problem. Okay, if they're 500K, it's a problem. But if they're within, I'm pretty sure those are 20% resistors. If they're within 20%, then that's not going to make a difference. And frankly, those disc caps, I've never had one of those go bad. So that's why I'm not saying that that's a likely problem, but it's a possible problem. If that cap was shorted, I think the top half of the screen would be all dark or something like that, but that's not your problem. So that's it for now. More later. I'm going to take a quick look at that schematic and see if you can check them in circuit. Let's go back to it real fast. Maybe I can answer that question for you real quickly. Let's see how well isolated this is. So we're looking right here. Okay. Clearly the 2 resistors you can definitely check, because that's 68K is isolated by this cap. So you can just connect your meter readings and see if this is close to 68K. And since that cap runs to the other side of the 100K, it's the same deal with the 100K. You should be able to just read the 100K on that deflection board. Now, these 2, now this you won't be able to check in circuit because you have all these other, if you connect up a cap tester between here and here, and without taking this cap out of the circuit, you're going to get all kinds of weirdness because it's going to read this resistor, this plate goes through all kinds of stuff. So if these 2 resistors check okay, the only thing you can do is take this disc cap out of the circuit and check it with a proper cap tester, when it checks for leakage and value. I would be really, really, really shocked if this cap was testing open, but I'm not saying it's impossible. I guess anything's possible. That's assuming everything else is checking properly. Like I said before, if you truly have a good CRT that checks out with good cutoff and blah blah blah, and you've got that grayscale all set up right, I can't possibly imagine anything else but this circuit causing your problem. Oh, and the AGC is correct, so you're getting a good strong signal. You have a good contrast and all that. Then I would be kind of shocked that this would be causing the problem. Because remember, your blanking comes from 2 points. It's coming from the blanking that's coming through this circuit from the vertical, and it's getting this blanking signal that's coming from here. When this this composite signal comes on, it blanks out at the vertical rate. So you know, every time this thing hits gets the vertical pulse come through, it cuts off the this as well. It sends a strong signal through here, and it drives this extremely positive, I guess the way it would be. I have to think about that for a minute. Let's see, yeah, it'd have to be positive to be turned off. So a negative pulse here would come through and turn this off. I think I'm doing that right. Yeah. Anyway, blanking takes place both from the composite video signal pulse and from the vertical pulse from the vertical transformer. But anyway, like I said, you can go ahead and check. I mean, I'd be more suspect that one of these resistors could have opened up rather than this cap going bad, frankly. But again, I mean, if it's within 20% of the 68K, it ain't gonna make any difference. Okay, if this was wide open or a million ohm, maybe then, well, definitely then you'd have a problem. Anyway, good luck with it.